Hello, everybody. I'm going to show you how we can do geometry in Rhino for 3D objects made on the laser cutters. So this little object here is just made out of cardstock. It's done in the round, and let me show you how simple it is to get this design ready. I'm going to start with a rectangle and make it 8.5 by 11 because that's the size of the cardstock we're going to work on. And all right, I need a vertical line in here for construction geometry. And now I want to consider this profile shape because the only profile shape we have to consider is this one. Because all the pieces of paper in the middle are round, they're all circular. Each one of these shapes should be the exact same. So if this is the very center of that structure with a curve interpolate points, I'm going to just mimic that round kind of vessel quality that it has. And I don't really like that, so I'm going to edit these control points a little bit. Bring this one closer. Okay, that might work. This could be interesting. I think maybe bring that just a little bit back. Okay, so um, I'll copy and paste this shape and bring the copy a little bit further away. And then with single lines, I'm going to connect the top and the bottom, and then join all of these things together in the command bar so that it's one closed curve added to selection. Then again with the curve single line tool, I'm just going to create horizontal lines, keeping them perfectly horizontal by holding Shift. And I just want 6 of these. You could do 5 or 4 or even 3. I think 2 might be too few. So let's see, what have I got here? 5. How about one more down low? I don't like that. That's fine. All right, so these lines represent the radius of the circular pieces of paper that are going to be in the middle of this structure. So at this point, if I select all of these lines and use mirror in the command bar, I'm going to use this construction geometry to situate the other halves of those lines on the other side of my construction geometry there. And then briefly hide this line so that one at a time I can join each of these lines together. Okay. And now I can show to bring that line back. And now each of these lines, these diameters now are what they are. They're going to be turned into circles. So with the circle diameter tool, let me start with this big one here. I'm going to start at this end and come over to the other end. And all right, this will fit on a sheet of paper, but there won't be a lot of room for anything else. So at this stage, you can sort of decide, do you want a circle that big or do you want to scale everything down a little bit? I'll probably scale the whole thing down just a bit. So, all right, I've got this circle, so I'm gonna scoot it out of the way now. That was the biggest one. So let's see. I'll start with the top here. Out of the way. Second one. Move this out of the way. Third. This out of the way. Fourth I got. So I just need the fifth. And sixth. So these are all the circle shapes that are going to be cut out of paper. There's one more thing that has to be done for each of them, and that is they're going to need a little slit, a little cut, so that the profile shape can slide into that. So how I'm going to do that is I'm going to look for, here's a midpoint right here on the circle. So I'm just going to draw this little line and then select that line and then array polar. The center of polar array will be the center of the circle. So I have to make sure my center snap is turned on and then choose the center while I'm in the array polar command. Change the number of items to 6. You can do whatever number works for you. You could do 3 or 4 or 5. I'm going to do 6 here. So 6 and then 360 degrees. I'm typing in 360 in the command line. And now I've situated all of these lines appropriately on the circumference. So I'm going to go around and do that same thing to each of these shapes. Array polar, center of the circle, 6 items and 360 degrees. Halfway there. Okay. So if I copy my 8.5 by 11 material boundary, I can start placing these circle shapes on here so that hopefully I can fit a lot of them here and save material and not waste too much. Probably one more. And I want to check to make sure I didn't accidentally leave behind any one of these little cut lines. That looks fine. All right. So these inner lines here, I'll tell you what, you can keep a little slit inside your profile shape. That way you have an interlocking joint, which is how these were brought together. But even as long as you've got a cut on the circular pieces of paper, you should be able to insert another piece perpendicularly into this one. So in this case, I'm going to try leaving these little cuts inside the profile shape. So I'll use the trim command, use the profile shape as my trimming object, and then get rid of everything on that side. All right, so this, I need 6 of these, right? So array linear 6 items, and I'll just set up a little array of these all here together. And let's see if hopefully I can fit all of these things together on the page. I bet I can. Okay, so on 2 sheets of paper, I should be able to build this now. So the design process for this is pretty quick. Depending on how things um, are actually cut, it could be a little bit of work putting them together because it's just paper after all. Let's say that you're less interested in doing something out of paper and you want to work with some of the wood that we have in the classroom. I would say still keep your design idea very simple. We're doing this for the very first time, most of us. And I would rather keep our design ideas simple. That way we understand how the manufacturing process is really going to work. Let's say that you want to try doing the same sort of simple in the round idea, but out of wood. The difference there is instead of a single line, you're going to want to create a rectangle, the thickness of which matches the thickness of the material you're going to be cutting on. So we've got basswood, for example, in our classroom. That is 3/16 of an inch, which I believe is, let's see, I'm pretty sure that's 0.1875 inches. Let me type this in and then double check real quick. So 0.1875, and then I'll just make it, a little bit taller. Let me double check to make sure that's really what it is. 3 divided by 16. Yeah, okay. So with this material thickness, the 3/16 of an inch, I'm going to move this rectangle from the midpoint on one line, get it on an end, and then slide it back until I have enough of that shape entering the circular wooden body. So trim, first of all, let me get rid of this line. Trim, I'm going to use the circle to trim away the rest of that, and then use the rectangle to trim away this piece. And now that I still have this portion of the rectangle, I'm going to do the array polar again. Array polar, center of the circle, 6 items, 360 degrees. And now at this point, I can get rid of these lines from before. And then with trim, I'm going to select all of these rectangles at the same time. And then trim away this piece of the circumference. And now if I join this, oops, into one closed curve, it'll cut this shape, and then another piece of wood 3/16 of an inch thick will be able to slide into this opening, making an interlocking joint like some of the ones I have on display in the classroom. So the technique is the exact same here, is these 3/16 of an inch, or let's say you find a piece of wood and you measure it and it's a 1/4 inch. You just want to make those rectangles the thickness of the material that you're going to be working with. And if something simple, you know, in the round, just a little vase or a ball shape is also not interesting and you want to push yourself a little bit further and you want to do something more um, you know, less radially symmetric, you'll still want to start with a material boundary of some kind. So I've got a couple slabs of wood in the classroom that are maybe 18 or 20 inches in one direction and then 12 to maybe 14 in another one. So let me just make a 14 by 20 rectangle. And in here, I'm going to start thinking about some shapes. So the little boat idea here, some people think this looks more like a little spaceship or something. Whatever this is, it's only a few parts. I think it's made out of maybe 6 separate pieces, and that's it. So it's not too bad. I'll start with an ellipse. Um, and I'll make a copy of this, so copy and paste, and I'll make the second shape a little bit smaller and maybe pull it back one direction. And I'll use a circle or some other shape, and I'll build that back here. And now I'll do some trimming. So with trim, I'll get rid of these inner shapes here. And, oops, actually I still need that. Do another trim. Okay. And let's see, I think I should probably make a copy of this too. So first I'll do a fillet back here. I've got a 1/2 inch. Let me try maybe a 1/4 inch over here. So fillet again, I'll change 1/2 inch to 0.25 and round these corners. Right click or control click to re-engage the previously used tool. That way I don't have to type in fillet again, and I'll join these into one closed curve. And now I can set this one up again. Fillet. This time I'm going to go back to the 1/2 inch fillet though. That way one shape has a slightly different character than the other one. And I may as well move this a bit now, just get that out of the way. Join all of these portions. So we've got a closed curve here and a closed curve here. I'll now use the smaller shape, copy and paste this, shrink it down a bit further. And when I select it, some of these control points, you can see they show up for me. So I can sort of customize this final shape here just by using control points. And for symmetry purposes, if I want to change like this control point and the second one, I can just add these lower points to my selection, and that way when I adjust them, the whole thing will be responsive. Okay, that's cool. All right. Now these pieces, just kind of like if I'm mimicking what I did here, these are going to be oriented horizontally, so they need a vertical piece of material to lock into so that they can remain upright. So that's where I'm going to draw some little legs that are going to hold this all together. So with the single line, I'll make a horizontal line and maybe use control point curve and just do some little curve like this. And then I can fill it again and maybe do a, let's see how ½ inch looks. That's fine. I'll join these together into one open curve, make a copy of it, and now I can just start to bring this shape into a close. So trim, use this line to trim off the upper piece here. Trim again to get rid of this piece. Join all of those, and then one more line right there in the front. So I can have, all right. Before I make a copy of this, I need some of those rectangles. So let's see, point 1875, right? That was our 3/16 of an inch. So here's a 0.1875 rectangle. And I want to do this symmetrically. So I'm going to use a single line as construction geometry, start it from the midpoint at the front, and then bring it all the way back here like this. With this rectangle, I want to get a nice even overlap with these shapes here. And once I feel like it's in a good position, I don't want to, for example, for this smaller shape, I don't want to bring it too close to the outside because that might not be great for stability, or it might not feel like a very secure connection. But I also don't want this rectangle to be too close to this construction line here, because the legs, I know it's, oh, yeah, these legs, if they're too close together in the middle, there won't be enough, it'll be more likely to tip over one way or the other. So a little bit of distance there is nice. All right, so I'll mirror in the command bar, if I can spell it right, mirror, there we go. And use this construction line as my mirror plane. This doesn't look right. Let me try that again. So these two rectangles, I'm going to need them for trimming operations, but I'm going to need to hold on to them. I'm going to need to use them several times. So I'm going to make a copy and then move the other copy 5 inches away. That way, I know I moved these 5 inches here. So if I, for example, if I do a trimming operation with this smaller shape here, so I'll use the shape to trim away this part and this part, retrim, except now I'm using these to trim away these parts. Great. But I need those rectangles back exactly where they were so I can do another trim for the middle shape and the biggest shape. So I'll use, by just clicking on the red arrow on the gumball, whoops, I'm going to move it -5 inches. So this way they're right back in that original position. And before I do the second trim, I'm going to make another copy and send these 5 inches away because I'm going to need these tools again. So trim, I'll use this middle shape to trim away these. Retrim, and now I'm using these rectangles to trim away those. And then I want to make sure that I join everything together. All right, so double checking here. I've got, whoops, an open curve. So I forgot to bring some of these together here. All right, this is a closed curve. So let me hide this for a moment and then join the rest of this. Okay. One more trim. So I don't need to make another copy of this, but I do have to move it 5 inches back. And trim, can use the shape to trim away the outer parts and use the inner parts to trim away this little bit here. Okay. All right, so just clicking on these here. One closed curve, closed curve, closed. Great. And now I don't think I need to do anything more here with these, so I can get rid of this construction geometry and start orienting these on my hypothetical material boundary. I don't actually know if the wood in the classroom is 14 or 20. Um, if you go and measure it, you'll know how to arrange your material boundaries and other important measurements here in Rhino. So lastly, I need to decide how these shapes are going to be organized on my two legs that are going to hold everything up. So, oh, and you know what? I think I want to have two of these shapes. That way, there's a little bit more of that round architectural quality where it's a little bit rounder. Uh, what am I trying to say here? It's the longest piece of it isn't all the way at the bottom. It's sort of in the middle, and it tapers as it gets towards the bottom. So I'll make a copy of this piece, and now I need to think there's going to be 1, 2, 3, 4 of these pieces grabbing onto this. So if I grab a point, uh, 0.1875, I can sort of now control where these are going to lock in to this. And maybe this isn't wide enough. Maybe I need to grab some of these control points here, like this one, just basically all these, and then pull these up a little bit more. That feels more secure. All right. So 1, 2, 3, and 4. And you know what? It's like you don't have to predetermine exactly how everything is going to look. It's fine to be a little bit surprised about how things come together in the end. The important thing that allows these 3D building techniques to work for laser cutting is that your material boundary and thickness are well considered. So if I do another trim here, I'm going to get rid of those. And one more trim to get rid of these. Join this into one shape. And then make a copy of this, because I need two. And this is the fun part, is figuring out how to get everything to fit on one piece of material so that you minimize how much wastage basically we have when we're making these. I think this something like this would work perfectly fine for building a rendition of this. Lastly, if you're more interested in something a little more artistic, it's all artistic. It's just what kind of subject matter we want to explore with these introductory laser techniques. If a little creature is more what you want to do, I'll spare a walkthrough for this, but just take a really close look and sort of reverse engineer this in your mind. We need something to reference so that we can get one, two, or maybe three profile shapes. And then we just have to figure out a little structure for them to lock into, which could be a very simple strategy, and it looks really interesting. So, okay, as far as Rhino is concerned, these are, I think, good, successful strategies for 3D projects. Don't bite off more than you can chew here. See if you can limit yourself to only doing a couple hours max worth of this work, because we still have some other interesting projects to get to, and we have opportunities to revisit 3D. Let me pop over to Adobe Illustrator for a second. I know a lot of us are more enthusiastic about Adobe Illustrator because it's familiar, and it's a wonderful platform. So let me just advise on a couple things for Adobe Illustrator. Let me I'm going to use the ellipse tool, holding shift to create a circle, and I'll use in the properties panel here the alignment tools to align it horizontally in the center and vertically in the center. With the pen tool, I can find, using that violet snap indicator, I can create one of these lines that we needed when we were using Rhino to get our paper shapes ready. And if you need to kind of replicate this array polar command in Adobe Illustrator, what you can try, although there are probably a few other strategies that will work, is you can, with the selection tool, grab that line, and you've got a rotate tool defaultly in your toolbar. If you right click this, oh wait, hold on, wrong tool. It's not rotate, it's, what is it? It's something else. Form. Oh my gosh. I've been at it for like 48 hours. Hold on. Give me a sec. It's right here. I know it. Rotate, scale, reflect, shear. Uh, it's basically this, repeat, but where is it up here? Object, transform. Okay, well, repeat is what we need, and it's going to be radial. And you'll get this icon here. Holding shift, I'll drag it out here. And let's say instead of 6, you had a different number in mind for how many of these repeated. this dial on the right is how you can adjust that. So it's that simple. Of course, I scaled the entire thing, so you'll need a smaller line to begin with. But all right, that's all I got for you for 3D. Have fun. Have a great time making these, and we'll start on plexiglass next week. Have a great weekend.